Today we're looking at properties of parallel lines. Let's look at our postulate. It says if two parallel lines are cut by a transversal, then corresponding angles are congruent. So with our hypothesis, we know that the lines are parallel. It tells us two lines are parallel, they're cut by a transversal, that we know for sure. The conclusion there is that then the corresponding angles are congruent. So in this example, we have our transversal is this T. Our parallel lines are P and Q. And again, they have this marker right here, which means that they're parallel. So corresponding angles, if you remember from the last lesson, they're angles that are in the same position. So for instance, angle 1 and angle 3 are in the same position. They're corresponding angles. So we can say that angle 1 is congruent to angle 3. 1 and 3 are in the same position. There are a lot of other corresponding angles which we can also say are congruent. Angle 2 is congruent to angle 4. They're corresponding angles. Angle 5 is congruent to angle 7. They're corresponding angles. And angle 6 is congruent to angle 8 because they are also corresponding angles. Since we're talking about congruency and not equality, notice again that we did not use that M symbol in front of the angles because we're not talking about a measurement, we're just naming the angles. Now let's use that postulate in looking at a proof. We're given that line K is parallel to line N, and we're trying to prove that angle 1 is congruent to angle 2. So my given information is that the lines are parallel. Now looking at the diagram, we notice that angle 1 and angle 3 are congruent because they are vertical angles. So angle 1 is congruent to angle 3, and we can say that is because vertical angles are congruent. Also because these lines are parallel, we can also say now, because we know about corresponding angles, that angle 3 is congruent to angle 2, and that is because, now we need to write the whole thing out. If two parallel lines are cut by a transversal, then we know corresponding angles are congruent. And in looking at step 4, our last step, we're trying to prove that, remember that angle 1 is congruent to angle 2, and we notice that they are both congruent to angle 3, so that makes them congruent to each other. Angle 1 is congruent to angle 2, and you just have to decide now if we have substitution method or if we have transitive, and it looks like we do have transitive property. So that's going to be my last reason, transitive. Now, what we just proved, if you go back to our diagram, we're proving 1 and 2 are congruent. 1 and 2, we call them alternate interior angles. They're on either side of the transversal. They are interior angles. So that is one of our theorems that we actually just proved. We're going to look at a few theorems today, and this one says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So alternate interior angles, they are congruent. So let's look at our diagram. So alternate interior angles would be 6 and 3. So I know angle 6 is going to be congruent to angle 3. They're alternate interior. I can also say that 2 and 7. Angle 2 is also congruent to 7 because they are alternate interior angles. And looking at our next theorem, we have if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. So same side, interior, meaning inside, and they're on the same side of the transversal. So 6 and 7, angle 6 and angle 7, they are supplementary. So that means the measure of angle 6 plus the measure of angle 7 equals to 180. We can also say that 2 and 3, they're also same side interior angles. So angle 2 and angle 3 are also supplementary because they are same side interior angles. And I like to remember that because of the S. S for same side, supplementary. They're not congruent. They are supplementary. Let's look at our last theorem for today. It says if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other one also. So again, we have our parallel signs here. We know that N and P are parallel. Right here, because of that box, we know that Q is perpendicular to N. So what this theorem is saying is if Q is perpendicular to N, then we also know that Q is also perpendicular to line P. That's what that theorem is stating. Now we're going to use our theorems that we've learned on some practical applications. So in this first one, again, here's my parallel lines. And sometimes I think it's helpful to extend the lines. So for instance, I know that this is going to be a transversal here. I like to be consistent. I'm going to make that in red, and I'll do that throughout on my videos. Make that transversal red. And now if I'm trying to include some other lines, I need to just use two other lines. So for instance, if I'm trying to make this angle right here 4x so I can work with it. There's one line here, and I'm also going to use this other parallel line here. So I know with those three lines, I've kind of enclosed my two angles that I want to work with. 4x and 14x, they're on the same side of the transversal. They're interior angles, so I know that they're supplementary. So I can say 4x plus 14x is equal to 180. So we know then that 18x is equal to 180, and x is equal to 10. So if I'm trying to find this measurement, this 4x, that angle is going to be now 40 degrees, and that 14x, that angle is now going to be 140 degrees. Now in trying to find the value for y, I do notice that I have a different transversal I'm going to work with here, this one right here. So I still have 2y and this 90, they're same side interior angles. So I also know that 2y plus 90 is going to equal 180. So again, I can subtract the 90, and I have 2y is equal to 90, so I know y has a value of 45. So again, I know that this measurement is going to be 90. So if they ask you what the value of x is, that's 10, and the value of y is equal to 45. Now again, I can check them. This is 90 and that's 90 because it's a right angle. That equals 180. I know they're supplementary. Same thing if I look at my angles dealing with x. I had 40 and 140. When I add them together, I get 180, which I know I'm supposed to get because same side interior angles are supplementary. Let's look at our next example. This is an interesting figure, very involved. So what I'm going to do first is I'm just going to kind of extend my lines. My parallel lines I'm making blue, just to extend them just a little bit. Now, if I'm trying to find x and y, I need to look at a few things first. It looks like that's going to be my transversal, so I'm going to make that red. Now, again, sometimes you just have to guess, and if it doesn't work, you try again. And I notice when I'm doing this that 61 and y are corresponding angles, and therefore they're congruent. So I can right away say that y is equal to 61 degrees. I also notice when I'm doing that 60 and x are alternate interior when I'm using this as my transversal. I have my two parallel lines here, and I made another transversal, which sometimes happens in the same diagram. You have more than one transversal. So I know again that alternate interior angles are congruent, so I can say x is equal to 60 degrees. And looking at our last diagram today, I have two sets of parallel lines. So these lines are parallel with a transversal here. Now I know that x and 3y plus 6, they are corresponding, so they're going to be congruent. So I have x is equal to 3y plus 6. Now I can't quite solve that because I have two variables in just one equation, so I'm going to have to work out something else. Now if I'm looking at the other direction and I look at a different set of parallel lines, for instance here, I have a different set here. So here's parallel lines here. And again, I have another set here. There's my transversal. I notice a couple things. I have 120 there. That's corresponding angles with 120 right there. Therefore, they're congruent. Now, when I do that, I also notice that I formed a straight angle with x. So I know that 120 plus x is going to equal 180. So I know x is equal to 60. Really wasn't a direct way to get there, but I did have to use all the information that I have. Now that's going to help me. First of all, I know what the value of x is, which is what I'm looking for. But that's also going to help me in this equation right here. Because remember, we said we couldn't solve right from there because we had two different variables and only one equation. So now I know what the value of x is, so I can make x is equal to 60, and that is equal to 3y plus 6. Now I can do some algebra, and I have 54 is equal to 3y. Divide both sides by 3, and I have y is equal to 18. So I have x is equal to 60 in this case, and y is equal to 18.